Hello, this is Mr. Collier, and today we're doing quadratic and cubic inequalities. Okay, so firstly we have a starter here, a quadratic starter. The equation of a curve may be written in the form, so this is factored form, and we're given a couple points of intersection. Find the equation of the curve. Okay, so we have it in factored form, and we see that the x-intercepts are -2 and 4, so we can write the equation as y equals a times x minus -2 times x minus 4. So that's a times x plus 2, x minus 4. Okay, next to find a, we can substitute in a point. We're going to sub in... what other point do we have? We have the y-intercept is -4, so we can substitute in 0, -4. Okay, so that's going to be -4 equals a times x plus 2 times x, x is 0 in this case, and 0 minus 4. So -4 equals -8a, a equals half. Okay, so the equation is y equals half times x plus 2 times x minus 4. Okay, next we're going to get into some inequalities. So to solve this one, this is a quadratic, and actually first let's think about what the graph would look like. That might help us out. Okay, so here we have, if we were to graph this quadratic, this is a quadratic that factorizes, so it's x minus 4 times x plus 2. And here is 4 and 2, sorry, -2 are the intercepts. And it's an upward facing parabola, so the parabola will look like this. And we're looking for x values, or values of x squared minus 2x minus 8, which are greater than 0. So that actually occurs here and here, because here we have values that are less than 0, here we have values that are greater than 0. Okay, so when x is greater than 4, and or x is less than -2, then this value here is going to be a positive number, so it's going to be greater than 0. Okay, so the graph helps you to determine that. Okay, another thing you could do is you could look at, well, we know at x equals 4 and -2, then this quadratic is equal to 0. So we could look at values between -4 and 2, or so -2 and 4, and bigger than 4 and less than 2, and see if those numbers are positive or negative. So between -2 and 4, we can plug in any number to figure out if it's positive or negative. If we plug in the 0 is pretty easy. If you plug in 0, you get -8, so this is going to be negative. If you plug in a number bigger than 4, like 5, you will get a positive number. And if you put in a number smaller than -2 and work that out, you will get, actually look at this one here, if we put in -2 or a number less than -2, you're going to have negative times negative is going to be positive. So you can also see it from the diagram that x is bigger than 4 or x is less than -2. Okay, in the next one, we have this. I'm going to multiply everything by -1 to make the x squared positive. Okay, now if we do that, then we change the inequality to less than. Okay, this is, if we factorize it, x minus 3, x plus 3 is less than 0. And that's an upward facing parabola, where this is -3 and this is positive 3. And less than 0 would be this section right here. Okay, so we say x is less than 3 is greater than -3. Okay. Now we don't have an example with this. If it was this case, I want to show that right now. If it was greater than or equal to, then our final answer would obviously include the endpoints -3 and 3. Okay, now next one is a cubic, and we can actually factor the GCF first. Then we have x squared minus x minus 20 greater than 0. So we have x times x minus 5 times x plus 4 is greater than 0. Now, even if you don't know what the graph looks like, we can still use the diagram method. Okay, so if this was just solving for when it equals 0, then we'd have three answers. We'd have negative 4, 0, and 5. Okay, so we need to plug in numbers between those values to figure out if it's positive or negative. Okay, so between 0 and 5, we can plug in a number like 1. If we plug in 1, then we're going to have 1 times negative 4 times 5. So it's going to be positive times negative times positive. So that's going to be negative. And over here, if we plug in a number bigger than 5, then all these terms are going to be positive. So the whole thing is positive. If we plug in a number like negative 2, then we'll have negative, negative, positive. So the whole thing is going to be positive. And if we plug in a number smaller than negative 4, we'll have negative, negative, negative. So the whole thing will be negative. Okay, so where are these values bigger than 0? It is here and here. Okay, so x is less than 0, less than negative 4, or x is greater than 5 is our answer. Okay, now before we go on to the homework, I want to show you how to do some of these and what the words mean here. Two distinct roots means two different roots, not the same number twice. Okay, so to answer these kind of questions, we use the discriminant. So remember that there's two distinct roots, then the discriminant is greater than 0. So you need to solve that inequality. Okay, and the discriminant is b squared minus 4ac, so you have to solve that. In this case, b is negative 1, so you have negative 1 squared minus 4 times 1 times k greater than 0, and then solve that inequality. Two equal roots, that's when the discriminant equals 0. So you solve that equation, it's not an inequality. And has real roots means the discriminant is greater than or equal to 0, because when it's less than 0, it has no real roots. Okay, so no real roots obviously is less than or equal to 0.